see. So this is my friend.
I am Aima Kimpun.
I'm Farhan Hanafi.
Hi, I'm Hasnisa binti Zakaria.
And I'm Sheila.
Okay, we are from unikl micet. We are taking chemical and bioengineering technology.
Yep.
So all of us are taking diploma. In this sem, we are going to study about transport process subject. In this transport process subject, we have done a lot of experiment, and now this is our mini project that we apply the experiment in the lab in our real life. So we're going to show you the simple way about the title that we choose, that is convection. So we are going to proceed to our experiments. First of all, we're going to the objective.
So now I would like to talk about what is heat transfer. Heat transfer by convection is one of the three heat transfer methods, which are conduction, radiations, and convections. Convection is form of energy transfer between a solid surface and the adjacent fluid. It undergoes the mixed effect of the fluid velocity and the conductions. The fluid velocity and the surface area effect are both proportional with the rate of heat transfer. Convection is the study of the conductions in a fluid as extended by its convective transport, that is, its velocity with respect to a solid surface, and thus combine the energy equations of first law of thermodynamics with the continuity and momentum relations of fluid mechanism. Heat transfer by simultaneous conductions and convection, whether free or forced, form the basis of the most industrial heat exchanger and related equipment. The measurement and predictions of heat transfer coefficient for such circumstances is achieved in the Hilton unit by studying heat temperature profile and heat flux in an air duct with associated flat and extended transfer surface, where it can be simplified in more simple way to understand it, where for free convections mean that is affected with the natural conditions with its surrounding. The forced convections, it means that it is affected when a force is applied in it. For example, when blowing a candle, air produced by moth is a type of forced convection heat. In this experiment, it will divide into two small experiments, consist of experiment 1 as a free convections and experiment 2 as forced convection. This experiment will let us to study the characteristic of each type of convections and differentiate it. This experiment exactly one of the applications of free convections and forced convections in real life. As we know, heat transfer is more effective when the surface area increases, where there are no resistance for the heat to go through. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Theory in this experiment. Convection heat transfer is the transfer of energy by the mass movement of group of molecules. It is restricted to liquids and gases, as mass molecular movement does not occur at an applicable speed in solids. It cannot be mathematically predicted as easily as can transfer by conduction or radiation, and so its study is largely based on experimental results rather than on theory. The most satisfactory convection heat transfer formula a relationship between dimensionless group of physical quantities. Furthermore, since the law of molecular transport govern both heat flow and viscosity, convection heat transfer and fluid friction are closely related to each other. Heat transfer can be improved by using a large surface area. However, in practice this is not always applicable. In free convection, small movement of air generated by this heat limit the heat transfer rate from the surface. Therefore, more heat is transferred if the velocity is increased over the heated surface. This process of assisting the movement of air over the heated surface is called forced convection. A heated surface experiencing forced convection will have a lower surface temperature than that of the same surface in free convection for the same power input. Thank you.
Hello, it's me again. Now I'm going to introduce the material and the apparatus that we are going to use in this experiment. First, what we have here is a matches, wooden matches, a clay, and a piece of paper as a fan. So I'm going to proceed to the procedure to do the experiments. In these experiments, we are going to do two mini experiments, which is one for the free convection and one for the forced convection. As you can see here in front of me, the procedure here, for the first experiment in free convection, set up the clay in the shape of square, arrange the matches on the clay with the difference between matches, each of it 0.5 cm, allocated matches starting point to burn it, the point A, here and here, and light up matches from A and observe the result. Same goes to the second experiment, which is for the forced convection. Repeat the first step and the second step in experiment 1, where set up the clay in a shape square and arrange the matches, and you need to allocate it in point A, of course. Same goes to the experiment 1. And for the forced convection, we are going to blow the matches, the burn matches, with a fan, the paper that we are going to use as a fan. Blow the matches, it shows that it applied a force on it. So that is the procedure. So we are going to do the experiments next. Okay, we're going to do the experiments now. Hi, it's us again. So we are going to start the experiment now. And now we are going to burn it. But first I will introduce which one is the experiment 1 and which one is the experiment 2. Here is the experiment 1, the forced convection. And here is the experiment 2, the free convection. In experiment 1, we will blow it using a fan, using a piece of paper. My friend here will going to help us. So that means a force is applied on it. So that is the means of definition of forced convection. So we are going to start to burn now. Ready? 1, 2, 3. 1, 2, 3. Okay, blow it. Okay, as you can see just now, for the forced convection, it burns more faster because a force is applied on it. And for the free convection, it burns naturally. So the burning is spreading a bit slower than the forced convection. So it can be concluded here that the forced convection is more effective than the natural one. So we are going to proceed to the discussion. What are we going to discuss about this experiment and the conclusion of the overall experiment?
Hello everyone. I will talk about the discussion in this experiment. First, the purpose in this experiment is to study the post-convection and pre-convection characteristics, to determine the difference between pre-convection and post-convection. In pre-convection, small movement of air generated by this heat limit the heat transfer rate from the surface. Therefore, more heat was transferred if the velocity increases over the heated surface. This process of assisting the movement of air over the heated surface called post-convection. A heated surface experiencing post-convection will have a lower surface temperature than that of the same surface in pre-convection. Convection heat transfer from an object can be improved by increasing the surface area in contact with the air. But in this experiment, surface area will not applicable, where in this experiment the main purpose is to differentiate between which type the convection is more effective. In free convection, it will take more time to burn completely, while in forced convection, it will burn fastly because a force is applied on it. That's all for the discussion, and thank you.
Hi, I'm Farhan. For this experiment, I will explain more about conclusion and recommendation of this experiment. Okay, as we know, the objective of this experiment is to study the force convection and free convection characteristic and to determine the difference between force convection and free convection. Okay, it can be concluded that this experiment has achieved the objective. For free convection, it will take more time to burn completely, while in forced convection, it will burn fastly because a force is applied on it. Okay, now the recommendation for this experiment is the distance between each matches affect the time taken for the matches to burn. Distance of between each matches must be fixed and determined well in order to get a better result. That's all from me.